So this one just came about because either someone asked me or it was a question in the book or something. But how would you find the points of intersection of the function and its inverse? So this is the function. I would find the equation of the inverse and then set them equal to each other. So my goal is to go, okay, so points of intersection means where are they going to be the same? So where they're going to be the same is when I'm going to do this. So I want the inverse to equal the function. So that's my goal. Okay, so that's my point of intersection is when they are equal to each other. So I'm going to say equal to each other, set them equal. So that is my plan. First thing I'll do is I'll find the inverse, which again, I did an easy one. So x equals 6y plus 20, bring it over. Right, used to this, divide both sides by 6, and you get x minus 20 over 6 equals y, and then, hopefully we're getting bored of this, therefore, this is the inverse. Right, so that's the inverse that we found. We went all the way through, we matched it. We take that, and we sub it in. So we get the inverse, we sub it in, and then we set them equal. So to find the points of intersection, you would set the two equations equal to each other. So we're going to go x minus 20 over 6 equals, and this is the original 6x plus 20. And solve. You're going to find your x's, or x. So bring the 6 up. So this will be x minus 20 equals 36x plus 120. Bring the x over, so it'll be 35x, and that over negative 140. And we divide, it actually ends up being exactly negative 4. Am I done? What's the question asked for? Find the points. Yeah, so don't stop there. Find the points. It's such a waste when you have all the hard part done. Point means you actually want the coordinate, right? So sub into either. Okay, you can sub into either equation. Because it's an intersection point, it's going to be the same in both. Yeah.
So doesn't the intersection point always appear at y equals x?
No, because when it overlaps on the other side, you can have two parabolas intersecting. I always get that question. So remember when you have two parabolas like this? And then what if it's intersecting at more than one, right? Because you can have more than one. It would intersect there. Try the opposite one, though, right? So we tried this as well. And it would intersect there and there. I know, I had this question with someone else. X equals x. Oh, no. It continues. And there's another one.
No, but that's still at y equals x.
Oh, wait. I know, we had this discussion last year, and I said, will it always be the same x and y value? We found a case where it wasn't. Oh, when the function's not parabola and stuff, so it does turn around. So when the function is not, we'll look at that one again, but we looked at it last year, and we were like, but we did find a case where it wasn't the same. Okay. I know, I had that discussion with someone else, and I'm like, but not always if the function has another. Yes, exactly. But it wasn't. We found a case where it wasn't because it's not always the simple case like this. I know. We looked at that last year too, and then we found a case where we're like, crap, so we can't use the faster way. So we plug this one in. It is negative 4, right? So f at negative 4 gets you 6 times negative 4 plus 20. I know, I did look at that last year, and I was like, but isn't it always? And then we were like, crap, there is a case where it's not the same. It will always intersect if the graph crosses at the same value. So negative 4, 2, 2, 3, 3. But is that the only intersection point? That was the question. And I think we came back with no. Okay, I know. We looked at that one too. Like, because it flips. Like if it was 220, it'd be 22. That could also be if they had a matching set. I know we looked at that last year and we found a case where there wasn't. Because I think we're looking at simple examples, so for the simple ones it works, but it doesn't always.